Good morning, everybody. I hope you guys had a great weekend. Today we're going to continue with Chapter 7, which is hypothesis testing, and we're going to jump into 7.2 a little bit. We did some basic definitions, vocab words. We introduced hypothesis testing last week. Today we're going to skip around. We're going to jump into 7.2 so we can start talking about those p-values or those probability values. So to start off, and if you guys hear squeaking in the background, I apologize. My dog is in crazy mode right now. We're going to first assume that the null hypothesis is true. Okay, so we're going to make the assumption that the null hypothesis is true. We perform a test according to the alternative hypothesis to see if our sample provided results that are so significantly unlikely to occur that we can then reject the null hypothesis. So we're checking to see if our sample provides us results that are extremely unlikely to happen. In that case, if we do get those results that are significantly unlikely to occur, then we can reject the null hypothesis. So during this test, we calculate what's called a p-value, and that's the probability of obtaining that sample statistic with the extreme values, or even more extreme than the ones determined from the sample data. So we're not actually jumping into the testing today. We're just going to discuss p-values, and you guys are going to do some examples, and then you'll have some tries on your own. So decision rule based on a p-value. To use a p-value to make a decision in hypothesis test, you have to first compare the p-value with alpha, or this level of significance. Okay, so remember that the level of significance is that alpha. Okay, so we take our p-value and we're always going to compare it back to that level of significance. So here's our first example. The p-value for a hypothesis test is 0.0237. Determine your decision when the level of significance is 0.05 and when the level of significance is 0.01. Okay. So again, all we have to do here is we have to take our p-value and we compare it to our level of significance. So for part A, because 0.0237 is less than our level of significance with a 0.5, you reject the null hypothesis. Okay, so since it's less than our level of significance, we reject it. Okay, again, if P is less than or equal to our level of significance, you reject the null hypothesis. If P is greater than our level of significance, then you never accept it, but you fail to reject the null hypothesis. So that's something we might want to write down here. Never accept it. You either reject it or you fail to reject it. All right, so next one, our level of significance is 0.01. So because 0.0237 is greater than 0.01, we say you fail to reject the null hypothesis. Okay? All right, and then just like we usually do, we're going to do all of the examples together, and then you guys are going to complete the tries for homework. So this would be one of your first homework problems, would be try number 1. Okay? Okay, so kind of tying it into stuff that we've done in previous chapters, the p-value is just equal to the area under the normal curve. So we're going to think back to chapter 5 when we did that normal distribution table. So we had our nice little bell-shaped curve. Okay, we had a z-value, so let's say this was negative 1.1, and we had this nice little chart. So if you remember this chart and what it looked like, we had our z-values going down the left and across the top, and then we just used it as a matrix to find the area that would lie under the normal curve to the left of that given z-value. So we're actually going to use this again, okay? So finding the p-value for hypothesis test after determining the hypothesis test standardized test statistic and the standardized test statistics corresponding area, you do one of the following to find the p-value. So if it's a left-tailed test, it's just the area in the left tail. So if we recall using these z-scores, it would just be use the area according to the z-score, okay? Now, if it's a right-tailed test, it would be 1 minus the area of the z-score, okay? If it's a two-tailed test, it's 2 times the area of the standardized test statistics because you have it on the left and you have it on the right as well, okay? All right, so first example, finding a p-value for a left-tailed test. All right, so let's take a look. We have our standardized test statistics, z equals negative 2.23. Decide whether to reject or, remember, we don't accept. We either reject or we fail to reject when the level of significance is 0.01. So we're going to sketch out our nice little bell curve here. And 0, 1, 2, 3. We've got 0, 1, 2, and 3, negative 1, negative 2, negative 3. And our z-value is negative 2.23, so that would be somewhere around here. So we're looking for this area because, again, it is a left-tailed test. So I know that my z-value is negative 2.23, so all I have to do is find the negative side of my chart. Okay. We go over to negative 2.2, which is right here in this row. And then we go over to 0.3, 0.03. So that is my area, is 0.0129. 0.0129. Let me just slide this out of the way. Okay, so our probability is 0.0129. Now that we have our probability, we compare it to our level of significance. And because 0.0129 is greater than our level of significance of 0.01, okay, we are going to fail to reject the null hypothesis. We fail to reject the null hypothesis. Okay, so that's how we do those problems when you have to use your chart. And the chart is just attached to your notes, so I would print it out if you have a printer available at home, because we will be using this chart pretty often. All right, so this is your second homework problem, is try number 2. Okay, finding a p-value for a right-tailed test. So again, let's kind of highlight our important information. We have our z-value is 1.23. Our level of significance is 0.10. And we know that this is going to be a right-tailed hypothesis test. So I always draw out the curves just out of habit. So we're going to draw our bell curve. 0, 1, 2, 3, negative 1, negative 2, negative 3. And our z-value is 1.23, which puts us about here. So we are finding this area. Now, remember, when you use your chart, z equals 1.23, the chart always shows you the area to the left of that z-score. So since we're trying to find the area to the right of the z-score, we have to do 1 minus whatever that area is. And just pull this up. All right, so we have 1.23. So we go down to 1.2, which is this row right here, and then over to 0.03, which puts us at 0.8907. Okay, 0.8907. So we're going to do 1 minus 0.8907, which gives us 0.1093, okay? So now we compare it to our level of significance, because 0.1093 is greater than our level of significance of 0.01, we fail to reject. The null hypothesis, okay? And then you guessed it, you guys are doing try number 3 as one of your homework problems. All right, last but not least, the two-tailed test. So we're just going to find one of the areas, either under the left or the right side, and then we just multiply it by 2. So we have our curve, 0, 1, 2, 3, -1, -2, -3. All right, and then we have our test statistic, which is z equals 2.14, and our level of significance is 0.05. We have a two-tailed test. So since our test statistic is positive 2.14, it's going to correspond to the same z-score, but with a negative, so also negative 2.14. Okay, so z is 2.14, or you could use negative 2.14, whatever's easier. I always just use the one that's provided, so we're just going to do positive 2.14, which means I'm actually going to start off by finding the area to the right, okay? So P is going to be 2 times that area to the right, so it's going to be 1 minus whatever it corresponds to. So now let's figure out what we correspond to. All right, so we've got positive 2.14. Okay, so we go down to 2.1 and then over to 0.04. This is putting us at 0.9838. All right, so minus 0.9838. That is going to give us 2 times 0.0162, which gives us a total probability of 0.0324. Okay. Now we have to compare that to our level of significance. So because 0.0324 is less than our level of significance, which is 0.05, we say we reject the null hypothesis. Okay? And then you guessed it, try number 4 is your last homework problem. Okay, so again, you don't accept the null hypothesis. You either reject it or you fail to reject it. We never say we fully accept it because you can't. It's just based on a set of sample statistics rather than the entire population. So do those 4 homework problems. You could do them on a separate sheet of paper if you want to print out the notes and do them right on here and submit as a PDF. As always, if you guys have any questions, just feel free to reach out. Otherwise, we have class again on Wednesday, so we will meet back then. Have a great Monday.